Differentiation. We differentiate the equation of a line to find its gradient. We will now show you some of the rules we can use to differentiate different types of functions. The constant rule. We use the constant rule to differentiate a single function of x. For instance, if we have y equals x squared, all we do to differentiate is we bring the power down in front of x, then we reduce the power by 1. This gives us dy by dx equals 2x. Another example of this is if we have y equals 4x cubed, the power of 3 comes down in front of x and multiplies by 4 to give us 12, then the power reduces by 1. So dy by dx equals 12x squared. The sum rule. We use the sum rule if we have two or more functions of x added or subtracted together. We treat each function of x the same as in the constant rule. For instance, if we have y equals 2x cubed plus 4x squared plus x plus 32, we again multiply the power by the constant in front of x, then we reduce the power by 1. We then move on to the next function until we have done this for each one. This will give us dy by dx equals 6x squared plus 8x plus 1. Note the constant 32, when differentiated, becomes 0. We use the chain rule to differentiate a function of a function. A function of a function occurs when a function is operated on again. 4 minus 5x cubed is a function of a function because 4 minus 5x has been operated on by being raised to the power of 3. To differentiate these equations, the chain rule is used. This is given by dy by dx equals dy by du multiplied by du by dx. Therefore, we substitute the inside of the bracket as u, so u equals 4 minus 5x. Therefore, y equals u cubed. Next, we differentiate both of these equations to give us du by dx equals minus 5 and dy by du equals 3u squared. Substituting these back into the formula gives us dy by dx equals 3u squared multiplied by minus 5, which simplifies to minus 15u squared. Substituting u back into the equation gives us the answer of dy by dx equals minus 15 lots of 4 minus 5x squared. The product rule. We use the product rule when there are two products multiplying themselves together. These are noticeable not by a multiplication sign, but when there are two products, such as uv. To differentiate these, we must use the following formula. dy by dx equals u dv by dx plus v du by dx. So when y equals x squared sine x, u will equal x squared and v will equal sine x. Next we differentiate these to give us u by dx equals 2x and dv by dx equals cos x. Now we will substitute these values into the equation to give us dy by dx equals x squared cos x plus 2x sine x. The quotient rule. We use this rule when needing to differentiate an equation in which one function is to be divided by another. The quotient rule is given by dy by dx equals v du by dx minus u dv by dx divided by v squared, where the numerator is u and the denominator is v. Therefore u equals x plus 2 and v equals 3x plus 1. Next we differentiate both of these to give us du by dx equals 1 and dv by dx equals 3. Next we substitute these four values back into the formula along with v squared. So dy by dx equals 1 lot of 3x plus 1 plus 3 lots of x plus 2 divided by 3x plus 1 squared. Once simplified, this will give us the answer of dy by dx equals minus 5 divided by 3x plus 1 squared.